Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it.
This is chapter 2.7, which is on nonlinear inequalities. All right, so let's go ahead and first look at polynomial inequalities. So solve polynomial inequality. So let's say I had something like x squared minus x minus 20 is less than 0. All right, so in here, we're going to start this off as if it was just a regular equation, all right, rather than an inequality. And by that I mean, well, let's see. Let's first factor this. We're going to factor this, and it's going to say it's going to be x minus 5 times x plus 4, right? And because that's negative 5 times 4 is negative 20, and negative 5 plus 4 is negative 1. Now, at this point, I'm going to look at this differently. I'm going to look at this as x minus 5 times x plus 4 equals 0, all right? So now I'm going to treat it as an equality or an equation, and this would give me then the solutions of x equals 5 and x equals negative 4. Now that I have that, I'm going to use these as test points into our inequality. What do I mean? So we're going to look at a number line, and we're going to say, well, here's negative 4, here's 5. And we're going to test around both of these into this inequality right here, into this line, so that we can see which size we care about. So for example, to test something to the left of negative 4, we can test something like negative 5. Between negative 4 and 5, we can test something like 0. And above 5, we can test something like 6. All right. Now, notice here that we're comparing it to 0. All right. The thing about 0 is it's an easy spot to test around, because if we're going to look for something to be less than 0, that means that we want a negative solution. If we're going to be looking for something that's greater than 0, we will want a positive solution. All right, so what we're going to do is we're going to see, well, when we plug our test points, what happens to this? Is it going to be negative or is it going to be positive? So let's see, when we plug in negative 5, negative 5 minus 5, that's a negative. Negative 5 plus 4, that's a negative. Overall, here we have a positive. So is a positive less than 0? No. So this tells us it's false there. Plug in 0. 0 minus 5, that's a negative. 0 plus 4, that's a positive. A negative times a positive is a negative. So overall, that's true, right? Because in here, a negative would be less than 0. Over here, when we plug in 6, 6 minus 5, that's positive. 6 plus 4, that's positive. Overall, a positive times a positive is positive. So in here, a positive is not less than 0. So therefore, it would be false. Now, to figure out our solution here, we're going to say, well, where is the region where it is true? And do we care about the actual points where it is equal to 0? Well, at negative 4 and at 5, it would be actually equal to 0. But in here, we didn't have the or equal to sign. So we're going to say we're going to put open circles on them and then just shade the part that is true. So what it tells us here is that our solution is now from negative 4 to 5. All right. Or you can write it as x is between negative 4 and 5, not including negative 4 nor 5. All right, let's do another one. And actually, before we do another one, let's see here graphically, what did we find? So for example, if I were to look at this this quadratic right here, and if I thought about the graph of it, well, what we found is that we have a graph something like this. It's something like that. And what we found was the region on the x values on which it is below the x-axis. Here's negative 4, here's 5. So in all of these x values here, the function is below the x-axis. Everywhere else, it would be above the x-axis. All right, so now let's look at another example. B. So let's say I had something like 3x cubed minus x squared minus 12x minus 4 is greater than 0. All right. So in here, well, the very first thing I'm going to do is I'm going to try to factor out as much as possible. And what I'm going to do here is I'm going to factor by grouping. I'm going to group the first two and then the last two. And when I do that, from the first two, I can factor out an x squared. And we're left with 3x minus 1. From the second two, I can factor out, oh, hold on, I copied this problem wrong. I wanted this to be a plus. There we go. From the second two, I can take out a negative 4. There we go. And now we're left with a 3x minus 1. So again, that should have been a plus from the beginning. And that's still greater than 0. And then I see here that we have the 3x minus 1. So we can factor out a 3x minus 1, and we're left with x squared minus 4. Right? And then here in the x squared minus 4, we can still factor that because it's the difference of squares, and it could be an x plus 2 times an x minus 2. All right, and we have that being greater than 0. At this point, that's where I'm going to treat this as an equation. So I have this, I'm going to look at this as 3x minus 1 times x plus 2 times x minus 2 is equal to 0. So this gives me the test points, or that we're going to test around the points of 1/3, around -2, and around +2. All right, essentially the zeros of this polynomial. And now we're going to look at our number line, and we're going to test those around this line. All right, because we're going to be plugging it in into here and then compare it to 0. So here's our number line. We've got -2, we've got 1/3, and we've got 2. Notice I put those in order, right, in numerical order. Now, to the left of -2, we can test something like -3. Between -2 and 1/3, we can test something like 0. And by the way, anytime you're using test points, 0, 1, and -1 are the easiest things to test in that order. 0 is the easiest, 1 is the second easiest, -1 is the third easiest. So whenever you can plug these in, definitely do so in that order. That's why I'm choosing to plug in 0. All right, so that was just a side comment. Now, between 1/3 and 2, I can test something like 1, and above 2, I can test something like 3. Now, the thing is, let's figure out what this does. So, plug in -3, and again, since we're comparing it to 0, all I care about is it going to be positive or negative? If it's positive, then it's greater than 0. If it's negative, then it's not greater than 0. So, let's see, plug in -3. 3 times -3 is -9 minus 1. That's negative. -3 plus 2. That's negative. -3 minus 5. That's negative. Overall here, I've got 3 negatives, meaning it's all going to be overall negative. Right? So, is a negative value greater than 0? No. So that tells us it's false in that region. So we don't care about that region. Plug in 0. 3 times 0 is 0 minus 1. That's negative. 0 plus 2, that's positive. 0 minus 2, that's negative. Overall, I have an even number of negatives. So that tells me that overall is going to be positive. So in here, it is true. Between 1/3 and 2, we're plugging in 1. All right. 3 times 1 is 3 minus 1. It's positive. 1 plus 2, positive. 1 minus 2, negative. Overall here, well, we have an odd number of negatives. So overall, it is negative. Plug in 3 also, because it's negative, we don't care about it, right? It's false. A negative is not greater than 0. Plug in 3. 3 times 3 is 9. 9 minus 1, that's positive. 3 plus 2, positive. 3 minus 2, positive. Overall, there's no negative, so overall this is going to be positive. So is a positive greater than 0? Yes, it is, so it's true there. Now, next thing. Here we have strictly greater than, so we don't care about the actual points of which it is equal to 0. And perhaps I should do this in blue like I did before. And then we're going to shade the parts where it's true. So from here, from -2 to 1/3, it was true. And then again, from 2 and beyond. So we can say here in interval notation that our solution is from -2 to 1/3 union 2 to infinity. All right, that's our interval notation. And again here, graphically speaking, we have something like this. We have something like that, where here, that's at -2, this is at 1/3, and this is at 2. And the question here is, where is this greater than 0? So in other words, where is it above the x-axis? And that would be in all of these values, and again, from here and beyond. All right, so the question here is, this this polynomial here, this cubic, where exactly is it above the x-axis? And it would be in all these regions. All right. So in general, that is solving polynomial inequalities. Now, let's kick this up a notch, and let's look at so solve the rational inequalities, and that is rational. All right, so we're at example C. So let's say that I had something like 1 over 2x plus 5 plus 1 over x minus 1 is greater than or equal to 0. All right, so now, in here, the very first thing that we have to think about in this problem is, what is the domain of this problem? All right, and that matters here. The domain of this problem here, it matters because we have certain values that we definitely cannot plug in. So the very first thing I'm going to do is take a note of our domain. So our domain is that x cannot be equal to -5/2 and x cannot be equal to -1, right? Excuse me, not -1, +1. Because these values would make these denominators 0. So we definitely cannot have those. Next thing we're going to do here is, well, let's come up with a common denominator. All right, so what we're going to have here is 2x plus 5 times x minus 1. Make that be greater than or equal to 0. And we end up with, well, x minus 1 plus 2x plus 5, right? And at that point, simplifying the numerator, well, x plus 2x is 3x, -1 plus 5 is a +4, and we still have this 2x plus 5 times x minus 1 is greater than or equal to 0. Now, at this point, we're going to do the same thing that we did before, where we treat this inequality as an equation, all right? So let's see, what do I mean? We're going to look at this as 3x plus 4 over 2x plus 5 times x minus 1 is equal to 0. At that point, we're going to say, well, we have a fraction here equaling to 0. The only possible way for that to happen is if the numerator itself is equal to 0, which here this then tells us that x is equal to -4/3, right? So we're going to have to solve around this. We're going to have to test around this as well as around these values. All right, so here we go. And by the way, we're going to test them into this line, the most reduced simplified line. All right, and here's our number line. What do we have? We have a -5/2, we have a 1, and we have a -4/3. So here's 1. Now between -5/2 and -4/3, which is the biggest one? Well, this is an easy way to check. You would do cross multiplication, so 3 times -5 is -15. 2 times -4 is -8. And you see, well, from these two, which one's bigger? Well, -8 is bigger than -15. So in here, -4/3 would be bigger than -5/2. So that tells us we have -5/2 here and -4/3 there. Now, let's see. What can we use to test around some things? All right, so in here, To the left of negative 5 halves, well, that's negative 2.5, so we can test negative 3. To the right of 1, we can test 2. Between negative 4/3 and 1, we can test 0. Between negative 5 halves and negative 4/3, well, negative 4/3 is negative 1.3 repeating. Negative 5 halves, we just said was negative 2.5. So in here, negative 2 would be somewhere in between these two. So we're going to test all these values into this inequality. And again, notice that we're testing, or we're comparing it to 0, right? So since we're comparing it to 0, we can definitely just see if it's positive or negative and know our solution. All right. So now, plug in negative 3. 3 times negative 3 is negative 9. Negative 9 plus 4 is a negative. On the bottom, 2 times negative 3 is negative 6. Negative 6 plus 5 is negative. Negative 3 minus 1 is negative. There's an odd number of negatives here, so overall it's negative. Is a negative greater than or equal to 0? No. So this part's false. Between negative 5 halves and negative 4/3, we plug in negative 2. All right. 3 times negative 2 is negative 6. Negative 6 plus 4 is negative. 2 times negative 2 is negative 4. Negative 4 plus 5 is positive. Negative 2 minus 1 is negative. Overall, there's an even number of negatives. So overall, this is negative. And again, it's a negative greater than or equal to 0. No, it is not. Plug in 0. 0 plus 4 is positive on top. Oh, hold on. There's an even number. I just realized I made a mistake. There's an even number of negatives, making this a positive. Meaning that this right here would be true, because a positive would be greater than 0. All right. Now, back to 0. 0 plus 4 is positive. 0 plus 5 is positive. 0 minus 1 is negative. There's an odd number of negatives here, so it's negative. And here that would give us false, right? Because a negative is not greater than 0. Plug in 2. 3 times 2 is 6. 6 plus 4 is positive. 2 times 2 is 4 plus 5 is positive. 2 minus 1 is positive. Overall here, this is positive, meaning it is true there. And now, well, we look at this. Do we care about these values, this value right here, where it actually is equal to 0 at negative 4/3? Yeah, we cared about it because of the or equal. So at negative 4/3, we're going to put a closed circle. But now we must also consider our domain. These values, from the very beginning, we weren't allowed to equal those, right? So at negative 5 halves, it's an open circle. At 1, it's an open circle. And then we shade the pieces where it was true. So in here, I end up with the solution being from negative 5 halves to negative 4/3, including negative 4/3, union from 1 to infinity. All right. Let's do another one. So let's see. D. Let's say we had something like x plus 2 over x plus 3 minus x minus 2 over x minus 3. And let's say that was less than or equal to 0. All right. Now, we're going to start again by looking at, well, what is the domain of this problem? The domain is, from the very beginning, x cannot be equal to negative 3 because we can't have a 0 in the denominator over here. And x cannot be equal to positive 3 because we have, that would give us a 0 in the denominator over here. All right. Next thing. So that's the domain of this problem. Next thing is, let's come up with a common denominator. So the common denominator is just simply x plus 3 times x minus 3. So now I have up here x plus 2 times x minus 3 minus x minus 2 times x plus 3, right? Because I need to essentially multiply this up here and this up here, and then we have this less than or equal to 0. Let's expand the numerator. So we have x squared, not plus, x squared minus x minus 6 minus x squared plus x minus 6, right? All of this over x plus 3 times x minus 3 is less than or equal to 0. At that point, we're going to say, well, in here, x squared minus x squared goes away. So let's see, we're trying to reduce the numerator. X squared minus x squared goes away. Negative x minus x, that's going to give us negative 2x. And then negative 6 minus a negative 6, negative 6 minus a negative 6, those are going to cancel out as well. So what we really have here is just simply negative 2x over x plus 3 times x minus 3 is less than or equal to 0. And now, this is where we're going to start looking at this as an equality. So we're going to look at this as negative 2x over x plus 3 times x minus 3. All right, and then we're going to say equals 0. And now we've got a fraction equaling 0. So we're going to say, well, the only possible way for that to happen is if the numerator itself is equal to 0, giving us a solution of x equals 0. So now we need to test around this value as well as the domain of our problem. Let's shift this down so we can see it. There it is. So we're going to test around all these values. So here is our number line. And we're going to say, well, here's 0 from here. Here's negative 3. And here's positive 3. And we need to test around all of these values, right? So let's say to the left of negative 3, we can plug in something like negative 4. Between negative 3 and 0, I'm going to use negative 1. Between 0 and 3, I'm going to use 1. And above 3, I'm going to use 4. So once again, I'm going to be plugging this into the most reduced inequality, just so that I can look at the sign. So I'm going to plug in negative 4. And again, all I care about is the sign, because we're comparing it to 0. So negative 2 times negative 4 is a positive 8, so positive on top. Negative 4 plus 3, negative. Negative 4 minus 3, negative. Overall, there's an even number of negatives here, so we're going to have this being positive. And is a positive less than or equal to 0? No. Between negative 3 and 0. Negative 2 times negative 1, it's a positive. Negative 1 plus 3, it's a positive. Negative 1 minus 3, it's a negative. Overall, there's an odd number of negatives, so this is negative, meaning and here is going to be true because a negative is less than or equal to 0. Plug in 1. Negative 2 times 1 is negative. 1 plus 3 is positive, and then 1 minus 3 is negative. Overall, there's an even number of negatives here, which means this is going to be overall positive. And is a positive less than or equal to 0? No. Plug in 4. Negative 2 times 4 is a negative. 4 plus 3, positive. 4 minus 3, positive. So overall here, this is negative, and is a negative less than 0? Yes, it is. So we end up with true there. Now, what values do we care about? Well, we know that we can't have negative 3 or 3 be solutions. So negative 3 or 3 cannot be solutions. And then at x equals 0, did we care about that? Well, yeah, because it was an or equal to problem. So we care about 0. And now that tells us now that our solution is going to be the interval from negative 3 to 0, including 0, union 3 to infinity, right? Because we're going to shade the stuff here where it is true. All right? Cool. Let's do another one. So that was D. E. Let's say that I had something like 4x minus 1 over x minus 6 is greater than or equal to x minus 2 over x plus 3. Sorry, over 2x plus 3. All right. So here we go. The very first thing I'm going to do here is I'm going to say, well, what is the domain of this problem? And here the domain is x cannot be equal to 6 and x cannot be equal to negative 3/2, right? Because 6 would make this 0, negative 3/2 would make this part 0. So we got to keep that domain in mind. Now, the next thing we're going to do here is we're going to put everything to the same side, all right? So when we do that, I end up with, well, 4x minus 1 over x minus 6 minus x minus 2 over 2x plus 3 is greater than or equal to 0. Oh, there we go. Scroll too far. There it is. So the next thing I'm going to do here is come up with a common denominator, which happens to be x minus 6 times 2x plus 3. And we're going to have that greater than or equal to 0. This 4x minus 1 needs to be multiplied by a 2x plus 3. And this x minus 2 needs to be multiplied by an x minus 6. All right. Now, at that point, we're going to say, well, let's expand as much as possible. 4x times 2x is 8x squared. 4x times 3 is 12x. Negative 1 times 2x is negative 2x. Negative 1 times 3 is negative 3. And we have that minus x times x is x squared. Then we get in here, this one's easy, negative 8x plus 12. All of this over, and I always leave the denominator factored. Never expand the denominator. At that point, we're going to reduce the numerator as much as possible. 8x squared minus x squared is going to give us 7x squared. 12x minus 7x, excuse me, 12 minus 2 is 10. 10 minus negative 8 is a positive 18x. And negative 3 minus 12 is negative 15. So now we have that over x minus 6 over 2x plus 3 greater than or equal to 0. Okay. Now, at this point, we're going to say, well, we can treat this as if it were an equation, right? We're going to look at this as 7x squared plus 18x minus 15 over x minus 6 times 2x plus 3 equals 0. And then we're going to say, well, we have a fraction equaling 0. The only possible way for that to happen is if the numerator itself is equal to 0. And now we need to solve this. Now, right away, I'm going to tell you that this is not a factorable quadratic. So we need to figure out another way of doing it, right? Well, we know when it's not factorable, we've got a couple of different tools at our disposal, including completing the square as well as the quadratic formula. And here, I want to use the quadratic formula. So, but what's it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is that? That's going to give us negative 18 plus or minus the square root of 18 squared minus 4 times 7 times negative 15 all over 2 times 7. Well, 2 times 7 is 14. Over here we have negative 18 plus or minus this stuff. All right. So at this point, this is where we take out our trusty calculator. And we see, well, 18 squared is going to be 324. A negative times a negative is a positive. 4 times 7 is 28. And 28 times 15 is 420. At this point, well, adding those up, 324 plus 420 is going to be 744. And all of that over 14. All right, now in here, this 744, I know it's divisible by 4, all right? Because I know the rules of divisibility for 4. Essentially, if the last 2 digits are divisible by 4, then the whole number is divisible by 4. So why do I care about that? Because, well, now that's going to tell me that the square root of 744 can be reduced to, well, it's going to be 4 times 186. So that's 2 radical 186. All right. So this gives me now negative 18 plus or minus 2 radical 186 over 14, which then reduces to negative 9 plus or minus the square root of 186 over 14. Now the square root of 186 is 12 point and change. And hold on, this shouldn't be over 14. It should be over 7. But I was saying it's 12 and change, all right? 12 squared is 144. 13 squared is 169. Oh, excuse me, between 13 and 14, because 14 is 196. 14 squared is 196. So it's between 13 and 14. It's almost 14, right? But the thing is, we want to use this as test points. So what we're going to look at is, well, this gives us a positive or a negative version, right? So negative 9 plus the square root of 186 over 7 is going to be about 0.6626, all right? And the negative version, negative 9 minus the square root of 186 over 7 is going to be about negative 3.234, all right? Now we want those just so that we can test around them, right? And we're going to use those as well as our domain, which perhaps I should copy and paste it a little bit further down, right into here, so we can be reminded of the domain of the problem. Now, in here, well, you know what? Let's do this. I'm going to copy and paste all of this, just so that it's not everything on top of each other. There we go. Right down here. Okay. So with all this information that we just found, this is where we're going to test around that. This is our domain, and we also need to test, this is what we're going to test into. And now that we do this, we're going to say, well, here is our number line. Here is 6 from here, because we can't be at 6. Negative 3 halves. Negative 3 halves is about negative 1.5. So exactly negative 1.5. So here's negative 3 halves. 0.6626. That'll be somewhere over here. 0.6626. And negative 3.234, somewhere over here. Negative 3.234. All right. Now, what values are we going to use? Well, to the left of negative 3, I'm going to test negative 4. Between negative 3 and negative 3 halves, I'm going to test negative 2. Between negative 3 halves and 0.6, I'm going to test 0. Between 0.6 and 6, I'm going to test 1. And above 6, I'm going to test 7. So we've got a whole bunch of things to test around here. All right. Now, let's do the easy stuff first. Testing in the denominator, because on top we're going to have to do a little bit of work. All right. So testing in the denominator. So plug in negative 4. Negative 4 minus 6, that's negative. 2 times negative 4 is negative 8. Negative 8 plus 3, that's negative. All right. Plug in negative 2. Negative 2 minus 6, negative. 2 times negative 2 is negative 4. Negative 4 plus 3, also negative. All right. Test 0. Negative 6 times 3, that's negative. Overall negative, right? Because, well, let's put it this way. 0 times minus 6 is negative. 0 plus 3 is positive. All right. Around 1. And perhaps I should put dotted lines here. Around 1. So 1 minus 6, that's negative. 2 times 1 plus 3, that's positive. And over here for 7, 7 minus 6 is positive. 2 times 7 is 14 plus 3. It is positive. All right, so now the question here is, what are the numerators doing? All right, well, let's do the easy one first. Plug in 0. 0, 0, negative 15. So that's negative, and that was plugging in 0. So overall, we have 2 negatives to worry about. So overall, this is positive. Is a positive greater than or equal to 0? Yes, it is. so it is true there. Let's plug in 1. 1 is the next easy thing here. 1 squared is 1, 7 times 1 is 7, 18 times 1 is 18, 7 plus 18 minus 15, that's positive. Overall here we have 1 negative, so it is going to be negative. It's a negative greater than or equal to 0. No, it is not. So in here we say false. All right, let's plug in the positive. 7. 7 squared, 49. 49 times 7 is 343. 18 times 7 is 126. So I have 343 plus 126 minus 15. Who cares what it is? Because it is positive. Plug in negative 2. 2 squared. Hold on, over here. We had no negatives, so overall this is positive. Is a positive greater than or equal to 0? Yes, it is. All right. Let's test negative 2. Negative 2 squared is 4. 7 times 4 is 28. 18 times negative 2 is negative 36. 28 minus 36 minus 15. Overall, it is negative. So here, how many negatives do I have? 1, 2, 3. 3 negatives. Overall, it is negative because it's an odd number of negatives. It's a negative greater than or equal to 0. No, it is not. Plug in negative 4. 4 squared. This is negative 4 squared, 16. 16 times 7 is 112. 18 times 4 is 68. Excuse me, negative 4, so negative 68. So we have 112 minus 68 minus 15. Overall, that is positive. We have here an even number of negatives, so overall this is going to be positive again. All right, so now I have that this is going to be true, right? Because a positive value is greater than or equal to 0. Now, these values, these decimal values, they came from solving this, right? We cared about those. Why do we care about those? Because we have an or equal to. So those values, we're going to fill them in. And then from our domain, we knew that we couldn't be at negative 3/2 or at 6. The next thing we need to do here is shade in the parts where it is true. So true here, and true for the rest of this. So I'm going to write our solution now. I'm not going to write it as decimals, by the way. I'm going to use the exact form that we got from the quadratic formula. So what we're going to say here is that our solution is now, well, this negative 3.234 came from, well, we're including it, so we came from negative 9 minus the square root of 186 over 7. And we're going to go, oh, so hold on. I messed that up. We're going from negative infinity up until that value, right? We're going from negative infinity up until that value. So up until negative 9 minus the square root of 186 over 7, including that value. Union, we're starting at negative 3/2, but we're not including negative 3/2, so we use parentheses. We go up to the positive version here, which was negative 9 plus the square root of 186 over 7, and we're including that as well. And then we're going to do union 6 to infinity, not including 6, because again, that was not part of the domain for this problem. All right. Let's do another one. So this was, what was E, I think? Yeah, E. F. So let's say that I had something like, well, actually, let's do this. Let's find the domain. And let's say I had f of x is equal to the square root of x squared minus 7x plus 10. All right. Now in here, well, what do we know about this? Here we have a square root function. So we know that when it comes to square roots, the inside, when we do the domain, the inside, the argument must be greater than 0. So x squared minus 7x plus 10 must be, greater than or equal to 0, right? Because you're allowed to have the square root of 0. But now, how do we solve this? Well, same thing as we've been doing before. Factor as much as possible. So this is x minus 5 times x minus 2 is greater than or equal to 0. And then we say, well, we treat it as an equal sign. So we look at x minus 5 times x minus 2. We look at it as if it was an equal sign. So we get x equals 5 and x equals 2. And, well, no, not that part. This part, again, is just how we treat it. The next thing we're going to do is, well, we're going to test around those points. So we've got the point of 5 and 2. So here's 2, here's 5. To the left of 2, I can use 0. Between 2 and 5, I can use 3. Above 5, I can use 6. So we're going to test those into this line right here, right? The most reduced inequality, because all we care about is the sign. So when we do that, well, what do we get? We get 0 minus 5, that's negative. 0 minus 2, that's negative. Overall, that's going to be a positive. Do we care about that? Well, yeah, because a positive is greater than or equal to 0. True. Between 2 and 5, we're plugging in 3. So 3 minus 5, that's negative. 3 minus 2, that's positive. Overall, a negative times a positive is negative. So is a negative greater than or equal to 0? It is not. Plug in 6. 6 minus 5, positive. 6 minus 2, positive. Positive times a positive is positive. Is a positive greater than or equal to 0? Yes, it is. So in here, we're going to say, well, do we care about these values, the 2 and the 5? Well, we do because of the or equal to. So we're going to circle those in. Right? And then we're going to shade the parts where it is true. And then we're going to say, well, our domain now is going to be from negative infinity to 2, including 2, union 5 to infinity. All right. Let's do another one like this, where we're looking for the domain. So let's say I said, find the domain of f of x being equal to the square root of 1 over 2x minus 1 plus x over x plus 2. All right. Well, right away, well, we're looking for the domain of this. So this is going to tell me, well, the inside stuff has to be greater than or equal to 0 because I'm working with a square root function, right? So I have right away that my domain is that 1 over 2x minus 1 plus x over x plus 2 must be greater than or equal to 0. But then at the same time here, I've got that x cannot be equal to 1/2 and x cannot be equal to negative 2 because those values would make the denominator 0. So we have to work around the domain of this problem, right? So the domain of this inequality is that, even though this inequality itself is a domain for this function. The next thing we're going to do here is, well, come up with a common denominator. So we have 2x minus 1 times x plus 2. Multiply, so x plus 2 times 1 is just x plus 2 plus x times 2x minus 1. Well, I guess we can just write it as 2x squared minus x. And what this gives us now is greater than or equal to 0. So combining like terms on the top, we get 2x squared plus 2, right? 2x squared. The x's cancel out, right? So I have x plus negative x. So I get 2x squared plus 2 over 2x minus 1 times x plus 2 has to be greater than or equal to 0. Now at this point, we're going to treat this as an equation, right? So we're going to look at this as 2x squared plus 2 over 2x minus 1 times x plus 2 equals 0. We've got a fraction equaling 0. The only way for that to happen is if the numerator itself is equal to 0. But look what happens here. I get x squared is equal to negative 1, which has no real solution. So because this doesn't have a real solution here, we don't need to test around these x values, right? Technically, this would give us x is equal to plus or minus I if we were working with the complex plane. But we're going to say, well, since we need to test around them, we can't use that. So since that has no real solution, and besides, we're looking for the domain of a real function here. So we're not going to use that at all. So we just need to test around these values into this inequality. All right. So we're going to say, well, here is our number line. Here is -2. Here's 1/2. We're going to test -3. We're going to test 0. And we're going to test 1. So plug in -3. And again, we're testing them into this equation. Excuse me, this is into this inequality. So we have, well, on the top. Notice that on the top, irrelevant of which value we're going to plug in, the top is always going to be positive. Now, why is that? Because we have something squared and then plus a number. So irrelevant of what this becomes is going to be positive on top. What we really care about is what's happening on the bottom. So let's see. -3. So 2 times -3 is -6 minus 1 is negative. -3 plus 2 is negative. Overall here, I have an even number of negatives. So overall here, this is positive, and that's where it would be true. Plug in 0. Well, on the top, again, it's positive. We already knew that. On the bottom, we have, well, -1 and then 2. So that's negative times a positive. Overall, this is negative, which would make it false. And lastly, over here, from 1/2 to the end, well, we're plugging in 1. Again, we already know the top is positive, but 2 times 1 is 2 minus 1 is positive. 1 plus 2 is positive. Overall, it is positive. So, is a positive greater than or equal to 0? Yes, it is. So what we have here is now, well, we know we couldn't plug in -2 or 1/2. So at those values, it's open circles. And then we shade the parts that we care about, the parts that were true. All right. So at this point, well, that would tell us now that our final answer is that the domain is from -infinity to -2, not including -2, union 1/2 to infinity, and not including 1/2 either. All right. All right. So that is the end of 2.7.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.